Hey guys, welcome back to Shrishti Tech Academy. Are you preparing for a technical interview at Infosys for a Java developer role? Then you are in the right place. I have come up with a series of 3 videos talking about the Infosys specific interview questions. In part 1, we discussed about Java specific interview questions that was asked in Infosys. This is part 2. In this video, we will discuss about Spring Boot specific questions that was asked exclusively in Infosys. Okay, how did I come up with this? I have handpicked and curated all these questions from different websites, even taking the help of ChatGPT to capture all the questions from different places exclusively that was asked in Infosys, together with the real questions shared by the developers who have already attended interviews in Infosys with a 2+ years of experience. I hope this video will be really helpful for you if you are preparing for your interview in Spring Boot, not only for Infosys, for any other company of that matter. I have got 30 interview questions. Now let us get started. Okay guys, now let us get started with the Infosys specific interview questions that was asked in Spring Boot. Again I am telling, it is not only for Infosys, anybody who is preparing themselves for interview in Spring Boot, this will be really of great help because this is an assortment of questions in Spring Boot starting from the basic till security part. Okay, now we will see the questions. So these are the questions. What is Spring Boot? What is the use of Spring Boot application? What starters have you used? Explain request param, path variable, request body. What is the difference between them? What are some common HTTP response codes? What is REST template? The different types of caching techniques. How to handle exception. How to handle validation. Explain the life cycle of a Spring Bean. Explain JWT token. Okay. What is Spring Boot? Spring Boot is built on top of Spring Framework. Spring Boot helps to develop production grade, ready to run enterprise applications. With the help of Spring Boot, you can develop console based applications, web applications, enterprise applications, REST APIs and also microservices. What are the advantages of Spring Boot? It supports simpler dependency management. It means if you want to develop a web application, it is enough you can go and pick and choose the dependencies. Automatically they will be added to your application. Default auto configuration. Spring Boot has a concept of auto configuration. It means if I am adding a particular dependency, based on the dependency that is added to the class path, the appropriate classes and interfaces will be configured. Suppose if I have added security to my application, it will automatically generate a login page, a logout page, a default username and a password. If I am adding web-based dependency to my application, automatically Spring Boot will add embedded Tomcat server. So this is default auto configuration. My dear guys, do not worry about this. Certain questions will come again, like what is the meaning of auto configuration. So during that time I will explain it. You have to combine everything and you can explain it for Spring Boot. Spring Boot has got embedded web server. It doesn't need an external Tomcat server or a web server to run the application. Spring Boot helps to get the application metrics and health checks. For this we use actuator as a dependency. It supports advanced externalized configuration. All the configuration needed for your application doesn't have to be a part of your application. It can be in a third party file. It can be in a third party repository also. Okay. Next question. What is the use of @Spring Boot application? When you create a Spring Boot application using Spring Starter project, the main class will be annotated with @Spring Boot application. It's a combination of 3 annotations: @configuration, @enable auto configuration, @component scan. The purpose of @configuration: when a class is annotated with @configuration, it can have any number of bean definitions. Spring Boot can read these bean definitions and it can create the Spring Beans accordingly. @enable auto configuration. The purpose of this annotation is to auto configure the classes, that is the Spring Beans, based on the dependencies that are added to the class path. If you are adding data.jpa, Spring Boot will automatically configure your data source, entity manager factory, transaction manager bean automatically. Add component scan. The purpose of this annotation is used for scanning the beans that are available in the current package and the sub packages. That is, it will go in search of beans that are annotated with add component, add service, and it has to create spring beans for those classes, that is objects for those classes. So that is done in the current package and all the sub packages. Next question. How Spring Boot works internally? This is a very important question. So how will you answer this? When you create a Spring application using Spring Starter project, a main class will be created and it is automatically annotated with add Spring Boot application. Now you need to explain the purpose of add Spring Boot application. Now when you run this application, the JVM gets an entry into the main method. Within the main method, there is a line called as spring application.run. When this method is getting called, this method bootstraps the application. Then it creates an instance of Spring application. Then it automatically instantiates the IOC container based on the type of application that you are working with. In case of a normal application, the application context will be created automatically. Then it triggers auto configuration, as in because we are using at Spring Boot application, we are having at enable auto configuration annotation. So it triggers auto configuration using spring.factories. This is a file which is having the details about all the classes that has to be loaded based on the dependencies that are added in the class path. It starts the embedded Tomcat server. Then Spring Boot application has got add component scan. It scans all the classes that are annotated with add component, add service, add repository, creates the objects for those classes, that is creates the spring beans for those classes and register those beans in application context. Now your application is up and running. So what you need to remember is, when you run the application, the first line within public static void main will be called, that is spring application.run. This method is responsible for bootstrapping your application, creating the IOC container, triggers the auto configuration using spring.factories, then it starts the embedded Tomcat server. If at all you have added web bus dependency, then because you have got add component scan, it goes and scans all the packages, that is the current package and the sub packages, identifies the class that are annotated with add component, add service, add repository, and creates the spring beans for those classes. Now your application is up and running. Okay, now let us see the pictorial representation of this. When you run your Spring application, the class annotated with that Spring Boot application is getting called because there is public static void main. It will enter into public static void main, call this run method, create Spring application instance, loads the application context, enable auto configuration. By default, auto configuration is enabled. If you want to enable the JPA repositories all by yourself, you can disable auto configuration also. We are enabling it, yes. So it loads auto configuration classes, then scan and register all the beans. Okay, now we will move on to the next question. How does Spring Boot auto configuration works? This is again a part of the previous question only. This is a feature that automatically configures your application based on the dependencies that are on the class path, whether it is a Spring Bean or the properties. How actually it works? The main class is annotated with at enable auto configuration. This is a part of Spring Boot application. It loads the configuration classes that are available in spring.factories file. The spring.factories file is inside meta-inf. It's not a part of our application, but it is available in meta-inf, which is a directory of Spring Boot jars. So it has got a list of auto configuration classes that has to be enabled based on the dependency. It means if you are using data.jpa, entity manager factory, and data source has to be enabled. If you are using security, security specific classes has to be enabled. Okay, see here. If someone is asking about Spring Boot, so the question may move from what is Spring Boot, how Spring Boot works internally, what is the purpose of enable auto configuration, what is the use of component scan. If you see the first 4 questions, they are interweaved. So you should know all these 4 questions. Next one, how is bean injection working? I don't have to even tell that. It is all about dependency injection, but there is a flow which we need to understand. So these are the steps. The first one is component scan, which already we have discussed. At component scan, scans the current package and the sub packages, looking in for classes that are annotated with at component, at repository, at service, at controller. It starts creating objects for those classes. Then the detected classes are registered as Spring Beans in application context. If a class has another class's dependency, the dependencies are injected automatically, either using setter based dependency injection or constructor based dependency injection based on what you have provided. For this we will be using the annotation at auto wired. In case of auto wiring, there are 3 types of auto wiring. Auto wiring by name, auto wiring by type, auto wiring by constructor. The default one is auto wiring by type. If more than one bean of the same type is available, we need to use at qualifier by specifying the specific bean name. If we are working with Java based configuration, we need to use the annotation at primary. There is a question about these 2 annotations. So in that we will talk about it in detail. How to inject a specific bean of the same type? If more than one bean of the same type is available, Spring Boot cannot pick and choose a specific bean. Then in this case it will throw an exception. No unique bean definition exception. Expected 1 but found so many, like how many ever in subclasses that you are having. In my case, I have got an interfaces I shape. I have got 3 implementation classes, that is triangle, rectangle and square. I want to inject only rectangle for this specific I shape. That is, I want to write the code as shape is equal to new rectangle. So we need to explicitly use at qualifier to pick and choose rectangle bean. If I don't write this line, we will get an exception. Okay. What is the use of at primary annotation? The previous one, whatever we have seen, is when we are working with annotation based metadata configuration. Assume a scenario where I have got multiple bean definitions in a class that is annotated with at configuration. If more than one bean of the same type is available, to pick and choose a specific bean, in this case we need to use at primary. So here I have used at primary. Okay, now one question. Assume a scenario where I have created the beans only using Java based configuration. Now I have used at auto wired and also at qualifier. Here I have used at primary. Now which one will have the highest priority? Always at qualifier will have the highest priority, because the initial stage is at primary, then it enters into the class, so at qualifier will have the highest priority. Okay, we will move on to the next question. What are the common annotations that you have used in Spring Boot? At Spring Boot application, at configuration. A class annotated with at configuration will have multiple bean definitions. A bean is nothing but a method that returns an object of a particular class. This is responsible for creating a Java object, which is also called as a Spring Bean. At rest controller. A class annotated with at rest controller will have multiple methods. These methods are nothing but our REST endpoints or REST APIs. A class annotated with at component will be identified by at Spring Boot to create an object for that particular class. This means it is a Spring Bean. At service. A class annotated with at service behaves as a bean of service layer. At repository. This annotation can be used above the class and also above the interface. If you are trying to integrate your Spring application with a database using JDBC, then you will be creating the implementation class and annotated with at repository. But if you are working with spring-data-jpa, your interface should be annotated with @repository. Okay. @entity. A class annotated with @entity behaves like an entity class. It means it is associated with the database. This class will be converted into a table in the database. All the properties will be converted into columns in the database table. @request body. Whenever a request comes from the user to retrieve the payload or the data that is there in the body part of the request, we use @request body annotation. To retrieve the data that is coming as a query string in the URL, use @request param. The last one is path variable. To retrieve the data that is coming from the URL directly, we will be using path variable. We will be discussing about path variable, request param and request body in one other question also. Okay, we will move on to the next question. What starters have you used in your Spring project? Don't directly jump into telling the starters. First explain what are starters. Spring Boot starters are actually third-party libraries which are added as dependencies in your Spring application. These third-party libraries are nothing but Spring Boot jar files. Internally, they have the Spring jar files. As in, if you are using Spring Boot version 3.5, internally this has Spring version jar files as internally it has Spring jar files with version 6.x. Okay, what are the different type of starters that you have used? Spring Boot Starter Web. This is used for developing a web application or building a REST API. If you want to integrate your Spring application with the database, use Spring Boot Starter Data-jpa. To authenticate and authorize your application, use Spring Boot Starter Security. Validation. To validate the input that is coming into the REST API. Spring Boot Starter Test. For testing our REST APIs. Spring Boot Starter Actuator. This is used for monitoring the health and metrics of your production ready Spring applications. Okay. Spring Boot Starter Logging to add logging. Spring Boot Starter Cache to add caching to your Spring Boot application. We'll move on to the next question. Explain the flow of a REST API call from the front end to a backend, response back to front end. This is so much, so I'll explain it with a pictorial representation. First, a request comes from the front end application to the backend REST API, that is to the Spring Boot. The request has a URL. It can be in the form of /register or /books. In case of /register, the data goes in the body part of the request. Now I want to get the list of books by a particular author. Here the data goes in the URL itself. When a request enters into a Spring Boot application, all the requests invariably will come and hit the dispatcher servlet. This dispatcher servlet is called as the front controller. It uses front controller design pattern. It means whatever request comes in, it will come and hit the dispatcher servlet only. Even before the dispatcher servlet, if you want, you will be having filters. That comes as the security part. After that, it will come and hit the dispatcher servlet. Now the dispatcher servlet is responsible for identifying the appropriate controller class. A controller class is something that is annotated with @REST-controller. The dispatcher servlet will identify the appropriate controller that is having a method that is annotated with /register or /book/author. After identifying the controller, now the request is in the controller layer. In this, it is in a particular method. Let's say I am having the method as add user, within which we are having the method annotated with @postMapping with /register. Now from the controller, we need to make a call to the service layer. Whatever we have seen till this part is the web layer. From here we are going in for infrastructure bean, which is our service layer. The service layer is responsible for handling the business logic. That is checking for exception, doing sorting, handling pagination, and all the other business logic that has to be done will be done in the service layer only. And also in this case, please understand, whenever a request comes in, it is a simple DTO object. Now the service layer is responsible for converting the DTO into entity. Now this service layer has a method which will call the method of repository. So from here I need to call the method of service layer method as in create user. So now my service layer has the method as create user. I will write it over here. This is the service layer method. From here we need to call the method of repository. So I will be injecting repository reference and I will call save method. So from here it enters into the repository. In case of repository, we will be having only one single interface because we are using spring-data-jpa, which is an abstraction for performing database specific operation. The implementation class for this repository will be created by Spring Boot during the runtime, and it is responsible for connecting to the database. Now the entity is saved in the database. This is one flow. What is the return flow? Now after saving the entity, it will return the saved entity. The saved entity is returned by the database to the repository. I mean, the Spring specific classes are responsible for performing the operation. They are going to give the saved entity. The saved entity is returned by the repository to the service layer. That is, it will return, this will be a return value of the save method. When it is coming to the service layer cannot send the entity back to the REST API, but rather it has to convert it. So the conversion of entity to DTO object again happens in the service layer. After doing the conversion, it will send the data to the controller. That is, from the create user, it will come back to the controller class. Now I have got a user object which is created. From the controller, again the result is returned back to the dispatcher servlet. The dispatcher servlet will take the data and return the data in the form of JSON. If the user is asking the data in the form of XML or any other custom content, that also will be given by the dispatcher servlet. Of course, that is done in the controller, that will be given by the dispatcher servlet. In the second case, the data comes in the URL of the request. In this case also, the dispatcher servlet will identify the appropriate controller having the method that has this particular URL. So this is how the flow works in a REST API. Now let me go back to the slide. We can just read through the lines. The request reaches the backend. The dispatcher servlet handles the request and it calls the controller class. Dispatcher servlet is also called as front controller because it uses front controller design pattern. Whatever request is coming, it will come only to the dispatcher servlet. That's why again and again I am using the same term, security or receptionist. Whoever is entering into a company, they cannot cross the security and go inside. They should meet the security or the receptionist. From there only they can proceed further. Now the controller layer executes. The method annotated with post mapping, get mapping with the appropriate URL is invoked. The method of the service layer is called from the controller. The service layer is responsible for taking care of the business logic, sorting, pagination, checking exception, converting DTO into entity, entity back into DTO. All that will be happening in the service layer. The service class method calls the repository layer using spring-data-jpa or JDBC to persist or fetch data. That is, either to save data or to retrieve data. The entities returned by the repository are converted into DTO objects in the service layer and they are sent to the controller. Now, in the controller, the results are wrapped, WRAPPED, wrapped by response entity and they are sent back to the front end. They are sent back to the front end by the dispatcher servlet. The dispatcher servlet will send the data either in the form of JSON or XML or custom content format. Okay, I hope this is clear. We will move on to the next question. How do you create a REST API in Spring Boot? Create a Spring Starter project. add Spring Boot starter web as dependency. Then create a class that is annotated with @REST controller. This class has got multiple methods which will behave as REST endpoints. Each method should be annotated with the appropriate mapping at get mapping, put mapping, post mapping. The return values from these methods can be wrapped using response entity and sent back to the client as response. The response can be in the form of JSON, XML or custom format. We'll move on to the next question. What is the difference between request param, path variable and request body? First we will understand what are these annotations and then we will discuss about the difference. @path variable. @path variable is used to extract the values from the URL directly. So the value over here is 1. This is the path variable. To retrieve this value, we need to use @path variable annotation. If the path variable name and the parameter name are same, you don't have to pass anything within the parenthesis. This is the most commonly used one to identify a resource. That is, the client prefers to attach the data in the URL and send it to the Spring REST API. Next, @request param. @request param is used to extract the values from a query string. The query string is nothing but if a data is coming from a form from the client side which uses get method, to retrieve the data that is coming from the get method, we use @request param. Actually, if the client is using a form with get method, the data will be attached to the URL after the question mark. This is called as query string. To retrieve the data that is coming from the query string, we are using request param. Here you can see after the question mark. Technically, this book ID is nothing but the name of a form field which is already available. From that form field, we are trying to retrieve the data. Okay. Next one is response body. Response body is used to bind the body part of the request into Java object. That is, when the client is sending the data of the form using post method, in this case the data comes in the body part of the request. Or if the client directly uses post method and attaches the data to the body part of the request, to retrieve the data we are using request body. The data comes as JSON, we need to deserialize it and convert it into a Java object. Whatever data comes in from the request is in the form of JSON. When you use response body, automatically this JSON object will be converted into Java object. The internal library that is getting used is Jackson. This response body is used together with post mapping and put mapping. Okay. So this is the URL. Here we are not attaching anything to the URL. Neither query string nor path variable. This means the data is coming in the body part of the request. We are using post mapping. Only while we are working with post mapping and put mapping, we will be having the data that comes in the body part of the request. Next, what is the difference between them? Path variable is used to extract the values from the URL. Request param is used to request the values from the query string. Response body is used to bind the body part of the request into Java object. The deserialization happens internally. In case of response body, it can be used only with post and put method. Okay, we'll move on to the next question. Which is the Spring Boot default server and how to use another server? We all know that the default server of Spring Boot is Tomcat server. Spring Boot also supports Jetty and Undertow. So how to remove Tomcat and add another server? When you add Spring Boot starter web as dependency, automatically Tomcat server will be added to your application. Now in pom.xml, you need to exclude Tomcat server and you need to include the dependency of Undertow or Jetty. This is how you have to do. I have added Spring Boot starter web. Now I want to exclude Tomcat server. So I have added exclusion as the XML tag. Now explicitly we need to add Spring Boot starter Jetty so that this particular server is configured for our application. We'll move on to the next question. What are some common HTTP codes and their meaning. 10 years before I got this question in an interview. Still now it is an evergreen question. Now let us see the response codes. If it starts with 2, they are all successful responses. 200, it means okay. You know, I don't have to tell that. 201, created. So when you are working with post mapping, use 201, which says that a new resource is created in the backend. Redirectional messages. 301, which means that this particular resource is moved permanently to a different URL. 302, found. This means the URI of the requested resource has been changed temporarily. New changes may be made in the future, but still you need to use the old URL only. That's the meaning. The client should use only the same good old URI for future request also. Next, client error responses. All 400 series comes under client error responses. This is not the fault of our REST API, but the request that is coming from the client side is wrong. 400 bad requests. Instead of giving a JSON format, if the client is sending the data in text format, if the URL is not formed properly, then we need to return 400, which is bad request. 401, authorization required. The status code is 401, the status value is authorization required. But actually, here we are checking for the client's username and password. If it is wrong, the REST API will return 401 authorization required. Then 403, forbidden. This is actually the user is not an authorized user. He is allowed to enter into the application, but he is not allowed to access this particular resource. Maybe only the admin is allowed to access a particular resource. If he is trying to access it, he will get 403, forbidden. The client does not have access rights to that particular content. 502, bad gateway. This means this server, which is expecting to get a proper response to handle the request, is getting an invalid response, means we will get 502. 503, service temporarily unavailable. The server is not ready to handle the request. So I hope it is clear. 200 series is successful responses, 300 series is redirectional messages, 400 series is client error responses, 500 series is server error responses. We will move on to the next question. What is REST template? REST template is a class which is used for communication between REST APIs. That is communication between services. It supports synchronous service to service communication. This REST template acts like a client-side HTTP utility and it consumes the REST APIs using HTTP method. That is, if I want to consume the method of one REST API from another REST API, means then we need to use REST template. We can call the other REST endpoints using the HTTP methods. Or if I want to consume the methods of one REST API from an MVC application. So this is my MVC application, this is my REST API. In this case also we will be using REST template, but REST template only supports synchronous communication. There are few methods that are available in REST template. Get for object, post for object, get for entity, post for entity, exchange, head for headers, put and delete. Let us see actually what it is. Get for object. It retrieves an entity using HTTP get method. This means from my REST template, I am trying to call the REST endpoint of another REST template using get for object. That is, I am trying to connect to a method that is annotated with @get mapping. So it retrieves an entity. Post for object. From my REST API, I am making a call to another REST API which is annotated with post mapping. This method creates a new resource using HTTP post method and it returns the entity back. Get for entity. In this case, again I am making a call to the REST API which is annotated with @get mapping. But this method returns a response entity. In the previous case, it returns a list. Here it is returning a response entity of list. In this case, it is returning one object. It can return a response entity of object, means then it is post for entity. Next is exchange. In this case, if I use exchange in my REST API, it can connect with any method that is annotated with any mapping, be it put mapping, post mapping, get mapping, delete mapping. That means it can communicate using any HTTP method, but the REST API will return response entity. Okay, put. If I use put, it means I make a call to the other REST API which is annotated with put mapping, which helps in updating the resource. Delete. I am making an API call to a method which is annotated with delete mapping, which is used for deleting a resource. Head for headers, which is used for retrieving all the headers. Post for location. It creates a new resource in the backend and it returns the location where that resource is created. Okay. So these are the methods of REST template. We will move on to the next question. What are the HTTP methods and their uses? I don't have to tell that, you all know it. HTTP methods define the type of the operation that the client wants to perform on a particular resource using REST API. If the client wants to create a new resource in the backend, he will use post method. If the client wants to retrieve the data from the backend, he needs to use get method. Okay. Now let us see that. Get. The client has to use get method to retrieve a resource. Use post method to create a new resource. To update the resource completely, use put method. To update the resource partially, use patch method. To delete the resource completely, use delete method. And to retrieve only the headers, use head method. There are two more subtopics that you need to understand. What are safe methods and what are idempotent methods? Get and head are safe methods because they don't modify the data. Get is used only for retrieving the data. Head is used for only retrieving the headers. So they are safe methods. Post will create a new resource. Delete will delete a resource. Put and patch will update the resource. So they are not safe methods. Next one is idempotent methods. Get, put and delete produce the same result how many ever times you call it. That is why they are called as idempotent methods. Okay, we will move on to the next question. What are the different types of caching technique in Spring Boot? This is mainly for experienced developers who are working in Spring Boot. Caching is a process to cache the results of a method. The purpose of doing this is to improve performance, to avoid repetitive processing, or to avoid repetitive database hits. Rather than hitting the database and getting the data again and again, I can cache the results and store it. Okay. In case of Spring, we have got Spring Cache module which provides a powerful abstraction for caching. That is a level above, which reduces the amount of work or the amount of code that we need to write. What are the different types of caching technique? In-memory caching, which is provided by Spring by default, EH cache, Redis cache, Hazelcast and Infinispan. There are few more also. Now, what are the annotations that we will be using in caching? At enable caching, it is to enable the caching at the application level. Caches methods return value, that is at cacheable. Cache put updates the cache without skipping the method execution. Cache evict to remove the entry from the cache. So if I enter into these annotations, then it will take so much of time. So you can just go through these. What are these annotations used for? We will move on to the next question. How to handle exceptions in Spring Boot? To handle exceptions in one single controller, create a method that is annotated with @exception_handler. Pass the exception that you want to handle. Within the method, write the logic to create a error object. Wrap the error object using response entity and return it back. Let me show you an example. Here there is a method which is annotated with exception handler. This method is responsible for handling book not found exception. My dear guys, if you are thinking in terms of Java, you usually have a try and catch. Catch is responsible for handling the exception. So here also the methods that are annotated with @exception_handler are responsible for handling the exception. So here you need to create an error object and return the error object that is wrapped by using response entity. Why response entity? Because I want to have the headers, the body part of the response, which is the error object, and also I want the status code. Response entity is a combination of header, body and status code. That is why we are returning a response entity object. Okay, next one. To handle exceptions in all the controllers of your application, you need to create a class that is annotated with @controller_advice. Within this, you can add methods that are annotated with @exception_handler. Suppose say, if you are creating a REST API, there are many inbuilt exceptions that may occur. Missing path variable exception, unsupported media type exception, missing request param exception, type mismatch exception. Similar to these, there are many more exceptions. If you want to handle these inbuilt exceptions, you can use the help of the inbuilt class. So, you need to create a class that extends response entity exception handler. Let me show you the example. Create a class that is annotated with @controller_advice, and this class should extend response entity exception handler. This class is responsible for handling the inbuilt exceptions that we were discussing. Unsupported media type, missing path variable, missing request parameter, type mismatch. So you can add those exceptions and you can handle it in your own way. Together with that, you can handle your own user defined exceptions just like what I have given above. That is, create a method annotated with @exception handler. This is the second way. One other way to handle the exception is annotate your custom exception class with @response status, so that when this particular exception occurs, the response status that you have given will be thrown automatically. Let me show you an example. In our case, we are having book not found exception. This class is annotated with response status and the status code is not found. So when this exception occurs, automatically you will get the status code as not found. Okay. One more thing, whenever you are working with exceptions, try to use meaningful status code. Return consistent error formats. As I told you, within the method, create an error object which can have properties as timestamp, error message, status code. Always log exceptions for debugging. This is one important point. When you are working in an application, you need to add logger statements for debugging purpose. Okay. This is how you handle exceptions in Spring Boot. First is create a method that is annotated with @exception handler. Pass the exception that has to be handled. Within the method, write the logic to create an API error object. Return the API error object that is wrapped using response entity. The second way is create a class that is annotated with @controller_advice. Within that class, you can add methods that are annotated with @exception handler. If your application is a REST API, if you want to handle the inbuilt exceptions like type mismatch exception or missing path variable exception, make your class extend response entity exception handler. Override the methods, write your own logic, create your own API error, wrap the API error with response entity and send it back to the client. Now the client will get a proper API error object with these properties as in timestamp, error message, status code, any other message that you want to add which you want to send it to the client. We will move on to the next question. How to do validation in Spring REST API? To perform validation in Spring REST API, use Bean Validation API JSR 380. Use the annotations in the DTO class. The annotations like not null, not empty, @min, @max, @email for the properties to handle the exceptions automatically. When a request comes from the client, the data is captured using @request_body annotation. That is, the JSON object will be converted into Java object. Now we need to validate the Java object. To validate it, together with request body, add @valid annotation. You can see the example given over here. @request body is used for capturing the data that is coming from the client. @valid is used for validating the data that is coming from the client. The validation is performed based on the annotation that you have given in the DTO class. If the validations fail, Spring will automatically throw method argument not valid exception. If you want to handle this exception, within the same controller, create a method that is annotated with @exception handler and return an error object that is wrapped using response entity. We will move on to the next question. How do you connect a Spring Boot app to a database using data.jpa? Now you need to tell the steps one by one. So let us just talk about the steps. The first one is you will be creating a Spring Starter project. Then we need to add the dependencies. For working with spring-data-jpa, you need to have the dependency as Spring Boot Starter data.jpa. Based on the database that you are working with, you need to add the appropriate driver. If it is MySQL, you need to add MySQL driver as dependency. The next step is whichever class has to be saved to the database, that model class should be annotated with the appropriate annotations as @entity. We need a primary key, so @id is mandatory. If you want to auto-generate the id, use @generated-value. And if you want to do some changes in the column, use @column annotation. All these annotations are added to a class whose object has to be persisted in the database table. Then create a repository layer. For this, create an interface, let's say book in repository, that extends JPA repository because we are working with MySQL. Within this, you need to provide the name of the domain model. In my case, it is book, and the data type of the primary key. The data type of the primary key is integer. This interface should be auto-wired in the service layer. From within the service layer, to perform CRUD operation, call the methods of CRUD repository, list CRUD repository or JPA repository. To perform other operations based on the properties, you can use any type of query, derived query, custom query, native query, named query. Okay. Together with that, it is mandatory that you need to provide the configuration details in application.properties file or application.yaml file. That is the data source specific properties. What is the URL, username and password? Then JPA specific properties, whether you want the table to be created or the table to be updated. That is whether you are starting from the scratch or you are updating an existing table. So these are the steps that you need to follow to connect your Spring application to the database. Let us cross check it over here. Add dependency Spring Boot Starter data.jpa. Add the appropriate database driver. Create model classes that are annotated with @entity and all the other relevant annotations. Create an interface that extends JPA repository. Pass the name of the entity class and the data type of the primary key. Add configuration details for data source and JPA in application.properties or application.yaml. Okay, we will move on to the next question. What are profiles and how to use them? Profiles help to provide different configurations based on the environments, development, testing, production. Guys, I have provided a video exclusively on how to work with profiles and also a video exclusively on how to do validation in a Spring REST API. You can check that out. I will add the link here. Profiles help in managing environment specific properties efficiently. Based on the environment that you are working with, you will have an appropriate bean to be created. You will have the appropriate application.properties file to be added. If you are working in dev profile, then you want your application.properties file to be application-dev.properties. If your profile is production, then your application.properties can be application-prod.properties or application-prod.yaml file. Create properties file corresponding to each profile. Create bean definitions specific to each profile. This is an example. Here I have two bean definitions. Both are for the same class. I am creating object for the same class only but with different set of values, each pointing to a different profile. The first one is for dev profile, the second one is for production profile. I have also added at primary to specify that this is the default profile that has to be selected. What if I want to set the add-to profile in application.properties or in environment variables or while running the application? How to do that? Let us see that. You can set the add-to profile in application.properties using spring.profiles.active. If you want to set the profile while running the application, then this is the command. How do you run a Spring Boot application? Convert your application into a jar file. Just like how you are running a jar file, you can run your Spring Boot application. Java-jar myapp.jar. My app is the name of my Spring REST API. This is the jar file that is generated. Together with that, you need to specify what is the active profile. _spring profiles.active. My dear guys, you can notice that the property is same. In this case, it is hard-coded in application.properties. In this case, while running the application, you are selecting the active profile. Okay, the third way, using environment variables. Export spring profiles active, that is production. Okay. How to set the default profile? Spring.profiles.default, or you can add primary. Okay. How to set multiple profiles? Spring.profiles.active, dev, AWS, QA. You can just add it, comma separated values. This is all about profiles. Again, I am repeating, if you want to learn about profiles in detail, I have pinned the video above. You can watch that. Next question. What is the use of a transactional? When you are working in a Spring Boot application, the transaction will be taken care automatically by Spring Boot. But if at all, if you want to handle the transaction declaratively, then you need to use the annotation at transactional. This annotation can be added in the service layer. It can be added either above the class or above the method. When will you use this at transactional annotation? Suppose say I want to perform the updation all by myself. As in, I want to explicitly use the update query. Till now, if I want to do updation, I have used save method. But now I want to provide the updation all by myself. In this scenario, from which method you are calling the method of the repository? That is where you are providing the update query. So, this method in the service layer should be annotated with at transactional. Or if you are handling the transaction all by yourself in all the methods, annotate the class with at transactional. So you can read it. The method or the class runs within a transactional context. So either all the operations succeed or all the operations are rolled back in case of exceptions. I have given the same example for update. In my repository layer, I have got a method update price by category. This method is annotated with at query where I am using update query. You can check it over here. And I am adding at modifying annotation. Now, this is not a part of querying the database. When you are using JPQL, you are using it just for querying the database. But for performing operations in the database, we are using the methods like save, delete. That is all the CRUD operations. That is creation, updation and deletion is taken care by the inbuilt methods. In this case, I am using my own query to update the record in the database. So, it is mandatory. Whichever method in the service layer is calling this particular query should be annotated with at transactional. I hope it is clear. Now, let me put it in simple terms. At transactional is used for managing the transactions declaratively. This annotation can be added above a method or above a class in the service layer. This ensures that the method or a class is within a transactional context. Either all the methods succeed or the operations roll back based on the exception. This is especially used with update query. Update, if you want to perform, usually we use save method. But now we are explicitly updating a record in the database. So it should either succeed or it should roll back. Any method that is calling this update query in the repository should be annotated with at transactional. That's it. We'll move on to the next question. Explain Spring security. This is actually a heavy topic, but how much ever is possible, I will explain it within this short duration. Try to grasp it and explain it in interviews. Spring security is a powerful module for authenticating and authorizing your Spring Boot application against the security threats. It's a common de facto standard for securing your Spring Boot applications, mainly in REST APIs and in microservices. When we work with Spring security, we need to understand certain concepts. They are authentication, authorization, CSR of protection, session management, password encoding. Authentication. This verifies the identity of the user, that is checking only the username and password. Authorization controls what the user is allowed to access. The user is allowed to enter into the website, but based on his credentials and roles, whether he is allowed to access a particular page or not is referenced by authorization. So, authorization verifies whether this particular user is allowed to access this particular page or not. Okay, next one is CSR of protection. This protects against cross-site request forgery attacks. Whenever a request is coming from the front end, it can be a viral attack. So, to prevent that viral attack, Spring Security helps to protect our application against this CSR of attacks. Session management. Spring Security is responsible for handling login sessions and logout. When you are even creating a basic Spring Security application, by default a login page and a logout page will be created and a default username and password will be given to you, an auto-generated password. Password encoding. Whenever a password is coming inside, the password will be encoded using certain algorithms. One such algorithm is bcrypt password and the encoded password will be stored in the database. Okay, this is a basic understanding. What is the architecture of Spring Security or what is the workflow of Spring Security? If someone is asking, you must be in a position to explain that also. Whenever a request comes in, already we have learned that automatically it will go and hit the dispatcher servlet. Whatever request is coming in, it will go and hit the dispatcher servlet. Even before the servlets, the filters come into picture. So, whatever request comes in, it will go through all the filters, then only it will enter into the dispatcher servlet. Okay, if we want to put it in simple terms, when you are entering into a tech park, first you need to cross all the securities, then you are entering into a company. In the company, you are getting connected with the receptionist, then only you are allowed to enter into the company. So, all the securities whom you are meeting are like filters and the receptionist whom you are meeting is like your dispatcher servlet. Okay, now in case of Spring Security, what is the architecture? Whenever a request comes in, it goes through multiple filters. Among this, one such filter is delegating filter proxy. This delegating filter proxy allows to bridge the gap between servlet's lifecycle container and our application context. Let me show you one more pictorial representation, that is this particular filter part. This is from Spring.io. You can just go and see the site also. So, this is our filter chain. More than one filters are available. So, it is a filter chain. Delegating filter proxy is there, which has filter chain proxy. Filter chain proxy is a special filter that is provided by Spring Security. It allows delegating to many filter instances through security filter chain. That is, I am having filter chain proxy within which there are multiple filters available. So, filter 0, filter 1, filter 2, filter 3, filter 4, likewise all the filters will be called one by one. Filter chain proxy is a bean, so it is wrapped inside delegating filter proxy. Delegating filter proxy is a part of the main filter chain, which is a part of your JEE, Java Enterprise Edition. Now we are having our security filter chain, which will call the authentication manager. The authentication manager takes the credentials as an input. Maybe the username and password or user ID and password or email and password. These details are checked using the authentication providers. There are different types of authentication providers: single sign-on, JPA authentication provider, JWT authentication provider, LDAP authentication provider. So, there are many authentication providers. The authentication providers are responsible for authenticating the user's credentials. So how it is going to do? For that we have got password encoder where the password will be encoded. So guys, as I told you, it's a huge process. What you need to tell is, an authentication manager gets the credentials of the user that has to be authenticated. The authentication manager will identify the appropriate authentication provider to check the credentials. For supporting this, we are having password encoder, we are having user detail service, which is an inbuilt interface. Once the credentials are checked, if the user is an authenticated user, then the authentication manager will return a logged in user, which is called as principal. The currently logged in user is called as the principal. And the logged in user will be provided with authorities. The authorities are nothing but roles. Based on the application, the roles will be given to the user. That's it. Now, let me just tell it in very simple terms. This is the Spring security architecture. Whenever a request comes from the client, the request has to go through multiple filters before it hits the dispatcher servlet. When it is going through multiple filter, one such filter is called as delegating filter proxy. This is responsible for bridging the servlet lifecycle and the application context. This delegating filter proxy is having filter chain proxy. This is a specific filter of Spring security. It allows delegating the request to multiple filters through security filter chain. The security filter chain will determine which Spring security filter has to be called. There are different types of filters. Username, password, authentication filter, logout filter. There are different types of filters available. Now, the credentials of the user will be given to authentication manager. The authentication manager will give the credentials to the authentication provider. There are different types of authentication providers. LDAP authentication provider, JDBC specific authentication provider, JPA specific authentication provider. They are responsible for checking the credentials. For that, there are different mechanisms. If the user is an authenticated user, then the authentication manager will return the currently logged in user, which is called as the principal. This particular user also will be provided with authorities, which are nothing but the roles based on the application. This is more than it. We will move on to the next question. Explain JWT token. JWT is JSON Web Token. It is a URL safe token format. Whenever you want to safely transfer information between two parties, JWT is the best bet because it is a digitally signed JSON object. What is the structure of a JWT token? It has got three parts separated by dot: header, payload and signature. Header specifies the type of the token and the algorithm used. Payload is the original data that you want to send to the other party. That is called as the claims. Signature is created by hashing the header and the payload together with the secret key. It verifies the integrity of the token. This is the JWT website. It has got three parts. This is the header, this is the payload and the last one is the signature. And the decoded data is given over here. This is the header which has the algorithm and the type. And this is the payload which has the details about the information that you want to send to the client. So the details about the subject, the name, admin, when it was issued, when it will expire, the email ID, what role that particular user is having, all the informations can be added in the payload. Then comes the signature. The signature is a valid secret code and the hashing of your header and payload added together. That will be your signature. This is how a JSON token will look like. How JWT token works? Let me explain that. When a request comes into an application for the first time, that is when a user wants to register himself to an application, he will be allowed to access that particular page without any authentication. Now the user details are collected and the user's data is stored in the database. This is the first flow. Once the user details are stored, now the user will be returned with this user ID and the data through which he can access the application. Maybe the username and password or user ID and password. Now the second flow is the user wants to log into this application. When the user enters his credentials to log into this application, this time also he will be permitted to access that particular page where the user's credentials are retrieved in the backend server. Now the authentication manager is responsible for checking the user's credentials in the database. If the user is not a valid user, an error page will be returned to the user saying authentication failed, wherein you will be getting 401. Now, if the user is an authenticated user, then in the backend server, a JWT token will be generated for this particular user with the header and the user details as payload together with the signature, some signature that is added to the JWT token. Now, this token will be returned as a response from the server. So, the JWT token is returned as a response. The JWT token will come and sit in the client's machine. If it is a front-end application, it will be stored in the local storage of the client's machine. If it is any other application, it will be stored in that server of that particular application. Now, what is the third flow? Now the user wants to access other URLs, as in the user wants to get the list of books by a particular author. The request has to enter into the application. When the user is sending the request URL, together with that, the user has to send a request header. The request header will have the JWT token. The request header should have the format as bearer space followed by the JWT token, whatever you have seen, something something dot dot, then the payload dot signature. So, this JWT token is added as a request header and sent to the server. In the backend server, the server is responsible for stripping up the JWT token. First, it will check whether it is a valid JWT token. If yes, then check for the signature. If yes, if the signature is valid, check whether the user belongs to this application. If yes, he is a valid user, then check for the role, whether this user is allowed to access this particular page. If yes, then the user will be getting his page what he was requesting. So this is the final flow. This is how JWT works. Now if the user wants to access any other page, let's say books by category or let's say add to cart, again here also in the request header, it is mandatory that the JWT token should be attached and sent back to the server. This is the flow. This is how it works. Every time it is mandatory that the JWT token should be added to the request header and sent back to the server. Okay, now let us check it out. User logs in with username and password. Backend validates the credentials and creates a JWT token. I am not starting from the first flow, I am starting in from the second flow. Okay, so user logs in. Now the JWT token that is generated will be sent to the client in the response body or as authorization header. Now the client stores the token in local storage. For every subsequent request, the client sends the JWT token in the request header as bearer followed by the token. This is how it is. I hope it is clear. We will move on to the next question. How to hide database passwords in Spring Boot? There are different ways of doing it. One is using environment variables, or using .env file, or using cloud config and vault, or encrypting the values in application.properties. The first one, using environment variables. In your application.properties, just use expression language. While running the application, set the environment variables and pass the username and password, whatever you want to send to application properties. The second way is create a .env file and place all the secret passwords in the .env file. Load the env file using Docker. The third way is using cloud config or vault. When you are working with cloud config, you will be having a separate properties file which is stored in the repository, which will have all the secrets. From your application, you will make a call to cloud config. Cloud config will provide the location of the repository from where you can get the credentials. Other than that, you can also use different types of vault. HashiCorp Vault or AWS Secrets Manager. Guys, I have not worked with AWS Secrets Manager and Vault, but I have worked with Spring Cloud Config Server. Encrypt the values in application.properties using the appropriate encryptors and decrypt them during runtime. We will move on to the next question. What is Spring Actuator and what are its features? Spring Actuator is a module which is used for providing production ready features in Spring REST APIs. It is a tool that is used for monitoring the health and getting the metrics of your application. Spring Actuator has certain REST endpoints through which you know about the details of your application. What are the beans that are available in your application? What is the mappings that are available in your application? Whether your Spring application is up and running? What is the health of your application? What is the metrics? What are the log details? And many more. You can also create your own custom endpoints. There are few endpoints that are shown over here. Actuator/health, actuator/info, actuator/metrics. If you want to learn more about Spring Actuator, I will add the URL of Spring Actuator here. You can watch that also. All that I will add it in the description also. Guys, this is a heavy topic. What is needed, I have just explained that. Just the 5 points for Spring Actuator. Spring Actuator is used for providing production ready features for your Spring REST APIs. It is a tool to manage and monitor your Spring application. It has got certain REST endpoints like health, info, metrics, logging, mappings to know the details about your application. You can also create your own custom REST endpoints using Spring Actuator. Few REST endpoints are given over here. Health, info, metrics. You can also explain that. We will move on to the next question. How to do multi-database configurations in Spring Boot? Add driver dependencies of both the databases. Add configuration details in YAML file. Create separate config classes. One for main DB, the other one is for the secondary database. Each class will have bean definitions. The bean definitions for data sources, entity manager factory and platform transaction manager. Use enable data repository separately. Among that, one will be the main database. Annotate all the beans in that particular class using @primary annotation. Keep the entity classes and the repositories for each database in separate packages. So these are the things that you need to follow when you are working with multiple database configurations in Spring Boot. We'll move on to the next question. How do you approach writing asynchronous non-blocking code in Spring Boot? If you are working in a multi-threaded application, especially working with Spring MVC and blocking IO, use async for quick asynchronous tasks. Or use Spring WebFlex, which use or in case of reactive web applications or reactive REST APIs, use Spring WebFlex with Mono and Flux. Mono is for returning one single object. Flux is used for returning a stream of objects. And here, instead of using REST template, use web client. Instead of using the normal database, use R2DBC database. This is used for working with non-blocking high scalable services. That is for working with reactive streams. We will move on to the next question. Explain the life cycle of a Spring Bean. Every bean goes through a life cycle that is managed by the application context. If you have gone through multi-threading, every thread has its own life cycle. Here, every bean has its own life cycle. These are the steps. Instantiation. First, the IOC container creates the bean instance using the no argument constructor or using a factory method. The next step is the dependencies needed for this particular Spring Bean will be injected either using constructor based dependency injection or setter based dependency injection. Next, bean name aware. If the bean implements an interface called as bean name aware, the Spring Bean calls setBean method to pass the beans ID. If your class is implementing any of this interface, then Spring calls setBean factory, this one, and set application context so that the Spring Bean knows about its container. So these are happening step by step. First is instantiation, then injecting the properties. Then if your class is implementing bean name aware, the bean is given an ID. If your class is implementing bean factory hour and application context hour, your bean will get the details about the IOC container, whether it is bean factory or application context, whatever it is, the details about the IOC container. Next is bean post processor. If your class is implementing bean post processor, you need to override two methods. One is post process before initialization. Another one is post process after initialization. This part will be taken care by us. Okay, what is the purpose of the first method? If you want to provide any custom modification before initializing the bean, you need to override this method, provide your details. Next, if you want to provide any proxies after the bean is initialized, you need to implement this method, post process after initialization. You can add proxies, that is if you want to add AOP, you can add this method. Okay, so this is an interface, you need to implement it and override the method, provide your logic. Between these two methods, the bean initialization will be done. It can be done in three different ways. One is using the inbuilt method. If your class is implementing initializing bean, you need to override after property set. Or you can create a method that is annotated with at post construct. Or you create a custom init method in XML or use Java based configuration. That is, you are having a bean definition for your class, then you need to provide init method. Among this, in which order it will be executed? First is annotation, then inbuilt method, then custom init method. Once the initialization process is done, then the proxies are added to the bean. That is the second one. Post process after initialization. Now your bean is ready to use. If at all, if it is a service bean, then it is ready to call the methods of repository, then ready to perform some business logic and return the data to the client. All that can be done. Now once your application is completed, when you terminate the application, what are the process that will happen? The context gets shut down. Method annotated with pre-destroy will be called. We used post construct, then pre-destroy. If a bean implements disposable bean, Spring will call destroy. This is an inbuilt method. Then the custom destroy method will be invoked automatically. So this is the life cycle of bean. So this is the order. First the bean is getting created, then the dependencies are injected, bean name our interface method is called, bean factory our method is getting called, application context our method is getting called, bean post processor method is getting called, that is before initialization, then method annotated with post construct is getting called, after property set, that is the inbuilt method is getting called, custom init method is getting called, then bean post processor after initialization method is getting called. Now the bean is ready to use. Once the application is getting terminated, the method annotated with pre-destroy will be called, then the method of disposable bean, that is destroy, is called, custom destroy method is getting called. This is the flow. I will add one video with relevant to life cycle of a Spring Bean so that you will get to know what is the purpose of each method and how it is working. We will move on to the final question. Can Spring Boot conditionally register a bean based on a property value? If so, how to do that? Suppose say there is a scenario where the user has a choice of selecting email notification. Whenever we are registering in a particular website, there is a choice for us to select it, whether we want to get email notifications about the upcoming events. If we select it, automatically we will get the notifications. If we don't select it, we will not get any notification. Now, to get these notifications, only if the user has selected it, I want to create a email notification bean, or else I don't want to create a object of this particular class. How this can be achieved? For that, the property that we are going to use is conditional on property. Conditional on property annotation helps to load a specific bean only when the feature is enabled in application.properties. Okay, now you can see here, this is my email notification class. The method is annotated with that component. This means an object of this class should be created by default, but it will not. Why? We have used one other annotation, conditional on property. Based on the value of this property that I have provided, feature.email.enabled, only if the value is true in application.property, the object of this class should be created. So here, in my application.property, I have given the value as true. It means the object of this class can be created. So the IOC container will create a Spring Bean for this particular class. So this conditional on property is a very important feature. So you are creating a bean only if that particular feature is enabled in application.properties. Guys, we have successfully completed 30 interview questions in Spring Boot in various topics starting from IOC, MVC, REST API, data-jpa and security. I hope this is really helpful for you in preparing for interviews. I also have one more announcement in this video. I am starting with a fresh batch of Java full stack from next week. If any of you guys are interested to join my coaching, please do check out the details in the description. You can book a one-on-one call with me and discuss the details. This is all about for this video. We are also having part 3 in which we will be discussing the questions on microservices. That's it. See you in the next video. Thank you.